Okay, go ahead and look at conjecture 25, because if I was to use Sketchpad right now, okay, and come up here, okay, and look at the sum of the interior angles, okay, in a triangle, does it matter what type of triangle, okay, that I do when I add up the sum of the interior angles? Will they always, and you can notice right here, that they're not changing. I have that 180 degrees right here. It's not changing no matter what type of triangle. Acute, obtuse, right? Is the sum always 180? So today's lesson is all about sum of interior angles and exterior angles measures. So go ahead and write a note to yourself and fill in 25. Conjecture 25 says the sum of the interior angles in a triangle is 180 degrees. It's 180 degrees. Okay? And you can do, your sketch sometime later or now. Draw a picture, put 43, 74, 68 in there. Okay, whatever they add up to be. Okay? And yeah, they add up to 180 degrees. Okay? My conjecture today is not just triangles, it's any polygon. How about, okay, for a quadrilateral? Okay, if I was to come up here and deal with a quadrilateral's interior angles.
Go with 300.
No, triangle, oh yeah, 360, I thought I said 180. Triangle is 180. Now what I want you to realize here is, does the quadrilateral have to be a rectangle?
No.
Now rectangle I know is 4 times 90 degrees is 360. But the only thing I do need is, notice these numbers are changing now. Why are the sum of the interior angles changing? What type of quadrilateral is this right now?
Concave.
Concave. So when we're talking about interior and exterior angles today, we're going to assume all polygons are convex for this conjecture to happen. And we can write down a note to yourself right now. Sum of interior angles in a quadrilateral equal 360. So the triangle was 180. A quad, just write notes down. It's not, actually it is one of the conjectures. I think that's 38. You can write down. Sum of the interior angles in a quadrilateral are 360 degrees. But I want you to have notes down, because you're going to have to see a pattern that's going to occur here. Because my goal is, I'm going to pick any type of polygon, and you find the sum of any type of polygon, without using Sketchpad, of course. The Sketchpad, I can come up here and I can do a pentagon, okay, and take this pentagon right here and move this angle around, no matter, just so it's not concave. You can see concave, it's not adding up to the right amount. But no matter what I do right here,
I got you. I see.
this right here adds up to 540. So go ahead and write down pentagon's interior angle sum equals 540. Okay, we'll do one more, and then I'm going to let you see if you can figure out what conjecture 39 is going to be. Hexagon's interior angle. Looks like right now, if it's convex, obviously, it'll add up to 720, no matter what type of hexagon it is.
What is it?
Okay, 720, but it has to be convex, because you can see here, if it's concave, it doesn't work. Okay, so if it is a convex hexagon, the sum of the interior angles is 120 degrees or 720 degrees. So on today's lesson, okay, we need to make a conjecture out, which is going to be our conjecture number 39. 38, we already did this. What was the sum of the interior angles in a quadrilateral? 360. Okay, that was conjecture 38. Now this one right here, conjecture 39, is going to help us find the sum of the interior angles in a dodecagon. And I'm not going to put a dodecagon on the Sketchpad and measure them. Discuss with your group members right now. What do you think this conjecture is going to be? You're two people. See if you can guess the conjecture.
If you do, however many sides are on this shape times 60.
So they'll get that would be that.
Well, 3,600 divided by
Yeah, 12.
600.
Okay, so 12. So how many?
It'd probably be like however many sides you've got.
Okay. Now, I'm going to come up here and I could give you this formula. And I think I heard most of you say n minus 2 times 180. And I could give it to you today. You may remember it tomorrow. You may remember it from a week from now. But are you going to remember it second semester? Okay, I'm not one that's a great memorizer. Okay, but I do use my dumb mnemonic devices. Or I use association of some sort. And that's what I was going to do when I did the lesson hands-on. Okay, but I'm just going to show you right now how I knew this came up to 360 is because if I was to draw a diagonal in, how many triangles did I split this up into? Two. One here and one there. Now, I could draw in another diagonal, I know that, but I didn't because, see, this interior angle and that interior angle together, they make angle F. And then I'd have this angle, and then this angle, and this one together make D. And this angle, isn't that all the angles in these triangles?
Yeah.
And two of those triangles, so 2 times 180, that was 360, which we were supposed to come up with. If I did that same thing now, if I was to draw in the diagonal this way, yeah, I know that makes 4 triangles, but it's going to make a lot of angles there that, are they really the angles of the quadrilateral? So that's why I only drew in that one diagonal from that one vertex. But on a pentagon, when I come up here on a pentagon's interior angles, I'm going to have one triangle right here, but if I would draw in the other diagonal from that same vertex, how many triangles do I get? 3 triangles, right? How many sides were there? 5, 3 triangles. Every triangle has to be 180 degrees. 3 triangles times 180 degrees is 540 degrees. Okay, I do that same thing for a hexagon. And I'm going to know when I draw this in that there's always 2 less triangles. And to me, my formula that I'm going to remember right up here is, and yes, some of you are still will remember it's always n minus 2. I always remember you take the number of triangles, because I remember that spatial, that visual thing that I just did up here with Sketchpad. And then he did that number of triangles. And I remember him drawing them from one vertex. So, next semester, oh, crap, I forgot the formula. Draw in the little vertices, because that's what I remember him doing. I can visually remember that. And there were always 2 less triangles. Every triangle was 180 degrees. So that's where, if you look at conjecture 39, I had 2 blanks. One was for the people, I guess, kind of like me, that needed a way to connect with the formula. I always saw the number of triangles, I remembered it, times it by 180. And there's some of you that give you anything, you memorize it, and you'll never forget it. Okay, that was never me. Okay, but here's the formula, n minus 2 times 180. Does it basically do the same thing? If you wanted to find out the sum of the interior angles in a dodecagon, what's the first thing you're going to have to know? Yeah, how many sides in a dodecagon? If you don't know that, then you're probably not going to be able to find the sum anyway. Okay, remember my mnemonic again was do was 2, decade was 10, so you're right, 12 sides. So if there's 12 sides, how many triangles are there? There's 10 triangles. And every triangle adds up to 180, so you better get your calculator out right now, because 10 times 180, you better type it in. It's kind of like I watch some of you, 3 times 5, okay, 15. Okay, and if your calculator told you 18, you'd write it down anyway, because that calculator doesn't lie. Okay, so we got 1,000, okay, and 1,800 degrees. That's the sum of a dodecagon. Start getting bigger and bigger. Question there on finding those? What happens if it was regular? Could you find each? What's regular mean anyway? Okay. All the sides and angles are equal. So in this question, example 3, I'm saying, what is one interior angle's measurement? Now, if it's not regular, can you find one interior angle? If it's not regular, you can't. But if it's regular, you can find the sum. So if I found the sum by taking the number of triangles times 180, what would I do then to find one angle?
Divided by the number of sides.
You take that sum and divide it by the number of, well, actually the number of sides isn't actually divided by the number of angles, right? But is the sides and angles the same thing? If there's 5 sides, is there 5 angles? Okay, so divide by the number of angles, which is the same as the sides.
Why is this almost?
Sorry, that's an angle symbol. I was abbreviating. Okay? So in this one right here, we know we want to find one interior angle. Okay, to find the sum, an octagon, we know octagon, octopus has 8 legs, 8 tentacles. Okay, so 8 sides. So there's going to be 8 triangles?
No.
6, because we got to take 8 minus 2. So there's always 2 less. That's the part you kind of have to remember on the visual. When I drew out the triangles, there was always 2 less triangles. Okay, so when we take this 6 times 180, did I do that right? 1,800 when you did the sum of all of them?
Yep.
1,000, sorry, I said it wrong, 1,080.
Yeah.
And then I divide that by how many angles there are. And so we take and divide 1,080. All right, 135 degrees.
Yeah.
Okay. Questions on finding those? Now, we don't have any questions on finding one interior angle. What happens if I gave you that interior angle? And I said all of the interior angles have the same measure. How many sides would there be? Okay, that's sides, right. But how do you find out how many sides there are? I mean, no?
Wasn't he on reverse the?
You do have to reverse it. So let's at least get the formula down. So on tonight's homework, the more you write down the formula, okay, the better off it's going to be. Show your work on tonight's assignment. Okay, one angle equals the number of triangles times 180 divided by, well, actually, let's change this formula, because don't we find the number of triangles by doing n minus 2?
Yeah.
And how do we find how many angles there are? So if there's n minus 2 triangles, isn't there n number of angles? And what is one angle's measurement?
140.
So you see, I put the 140 not in on the right side of the equation like I did over here. You notice I put everything over here on this right side of the equation here and found out that one interior. Well, this time, okay, I know the answer. It's 140 for one interior angle. Well, how do we solve this? I mean, if you remember some of your algebra skills, if I put that over 1, and let's say I distribute this, because I think all of us know how to do that. And you saw that something that looked like that. This should bring back at least a little bit of a memory from last year. I don't know if you guys remember doing problems that look like this. Yeah, this is called, what do we call these things when you have two ratios that equal each other? I don't know, I just remember how to solve them.
Yeah.
You don't remember that they're called proportions?
Yeah,
Okay, proportions, we solve them by doing the cross product property. Okay, we get 7x equals, okay, 18, 3 times 6. Well, that's what we have essentially right up here if I put that 140 over 1. Okay, yeah, some of you said, well, I could divide by n, why don't I just times by n? Okay, that would eliminate it. It's the same thing. It would get 140n equals 180n minus 360. Okay, so subtract 180. Negative 40n equals negative 360. Looks like it's a nonagon.
do it.
A nonagon. That is going to be some of you typing your calculator in and just start typing in numbers and dividing it out and guessing and checking. I'm not going to accept any guessing and checking answers. Okay, you're going to have to come up here and solve. Okay, so solving on this one takes a couple steps. Okay,
Pretty easy one, you think?
not too bad.
We're going to your
Yeah,
Yeah.
compared to Euler's line. That's a little shorter. Okay.
Yeah, this is a little.
All right. Next thing that we're going to do is this is everything we wanted to do about interior angles.
Oh no, are you
Okay.
doing exterior?
Now we're going to talk about exteriors. I know they're going to be terrible. First thing I want you to do is get your straight edge out and draw a polygon. Try to make it as non-regular as possible. I don't care what type of polygon it is.
Does it have to be concave or convex?
Please make it convex, because that's all the things we're talking about today is convex polygons. Okay, so your first step right now is, I would like you to draw any type of polygon. I don't care what size, what shape it is. And just make sure that it is convex. Because what we have to learn how to do is, we're going to try to find the sum of exterior angles, but I don't think some of you even know what an exterior angle really is. Can you draw one in, or just tell me where it is?
Yeah.
Draw an exterior angle in. Alright, I can't use my straight edge with my smartboard. I could use straight lines if I needed to. Okay, but I'm just going to freehand my polygon. I made a quadrilateral. Okay? Now, the one thing I had a feeling most people would do is the definition of an angle, it has to be between 0 and 180. And some of you said, there's an exterior angle, which is already false because is that an angle? No. Okay, so those of you that did that, let's go back and revisit how do we make an exterior angle then? Do you just come over here and say, oh, here's an exterior angle then right there? No, these lines are not parallel, they're just kind of drawn up there. But the one thing I do want you to know is interior angles and exterior angles are linear pairs to one another. So you take your straight edge, right? Okay? And we are going to take your straight edge and extend a side straight out. If you extend a side straight out, okay, this angle right here, that is exterior. The question that I have for you is, how many exterior angles are in your polygon? First of all, I want to see, just by show of hands, show me how many sides on one hand. Show me how many sides you put Drew. Okay? On your other hand, show me how many angles there are. Interior angles there are on your other hand. Everybody has the same number of fingers up on both hands, right? Because if it has 4 sides, it has 4 interior angles. So now, my question is that true for exterior angles? If I have 4 sides, will I have 4 exterior angles?
No. Yeah.
No.
Yeah, this is always the misleading part because I always have somebody do this. Why didn't I, here's angle 1.
I think it needs.
What's true about angle 1 and 2 right here? So if I did this exterior angle here, why would I bother drawing in this other ray to make angle 2 when angle 1's already the exterior angle? And then I have some of you counting this angle right here, angle 3 is an exterior angle because it's outside the triangle. But really, what's true about angle 3 and angle 4? They're equal. So this angle 3 is not an exterior angle. That's not an exterior angle because it's the vertical to an interior. This angle 2, we don't need it because we already have it with angle 1. So the only thing you need anytime that you draw an exterior angle is the extension of a side. Okay, take your straight edge and extend a side out. So go ahead and do that for all your exterior angles right now. In fact, if a quadrilateral is going to have 4 exterior angles. Okay, if I come back here to Geometer Sketchpad and I look at a triangle's exterior angles. Okay, a triangle has 1, 2, 3 exterior angles. And in fact, when I added up these exterior angles right here, if you notice right here, as I try to make one of these angles right here, if I make this angle right here bigger, what's occurring to this exterior angle? Sorry, right here. My finger's in the way. This one's getting bigger. What's happening in this one down here? It's getting smaller. When I make this one right here bigger, what's happening to the top? DBG. Smaller. What's the sum always adding up to be? So make that note. In exterior angles of a triangle equal 360. We're going to try to make a conjecture here about exterior angles and polygons. Okay, how do we calculate the sum of the exterior angles and polygons? Okay, come up here to a pentagon. Now, if you were to watch this, if I was to watch my finger up here, because I'm going to have to point. Angle J, if I was to make it 2 degrees bigger, what's happening to angle K? As I make angle J bigger, what's happening to K? No, K's right here. It's getting smaller. Okay? So every angle that I make J bigger, K is affected. So in fact, if you look at my sum, because that's true, obviously it has to be K convex. But no matter what I do, what is the sum of the pentagons? Exterior angles. 360. How can that be? A triangle's 360? A quadrilateral's 360? A pentagon's 360? A hexagon? Okay, that right there is going to be 360. See, I added all those up. They come out to be 360. In fact, if I was to make this thing a 20-agon, or even worse yet, 100-agon, what type of shape am I getting it close to resemble? And circles, they're close to looking like a hundredagon. And a hundredagon equals 360. And what is a degree angle of a whole circle when you measure it? 360. Okay, that's where that, is very similar to. The circle ends up being the most regular type shape you can get. Okay, and that's where it's 360. So the exterior angles all end up being 360. So if I come back here and I was to ask you to, put in your conjecture, which I think is conjecture 40, which unfortunately I forgot to delete the blank. Okay, it says that the sum of the exterior angles, no matter what type of polygon it is 360. So my question that I have here on this one is, what's the sum of the exterior angles in an undecagon? 360. Did it matter if I would have put this as a 101agon? No, it doesn't matter. Okay, but my next question is okay, now if this is a regular undecagon, a regular one, what's the measure of one of them?
Interior?
No, exterior. We're still on the exterior thoughts.
So you have to divide by 11.
Well, that's not too bad, is it? Divide what by 11?
360.
So divide 360 by 11. Doesn't come out to be nice here. Okay, 360 divided by 11. So,
Oh, you're using the calculator.
yeah, you're right, because this one came out to be 32.72 repetants. So, 32 and 8/11 degrees. Yeah, you can divide it out. This didn't come out nice. Okay. Now, what happens if I know every exterior angle is 45 degrees? If every exterior angle is 45 degrees, could I find out how many sides a polygon has? I mean, what would I do?
360 divided by
360. What I want to do is see how many of these 45-degree angles will add up to 360 degrees. And this is not bad. I mean, what we've done so far, it's pretty simple work, right? Okay? Have a little contest for us to see who's the quickest at solving a problem. Okay? We know Nate won't win, so everybody else, you ready? Okay, this next problem, I want to see who can get it the quickest. Okay? How many sides does a polygon have if each interior angle is 160 degrees? Ready, set, go! Go, Nate, go! Each interior angle is 160 degrees. Now on tonight's assignment, you got to show your work. Some of you are just putting numbers in the calculator. Actually, most all of you guys are doing good. I had some people last hour started putting numbers in their calculator. Nate, you got it. What'd you get?
18.
Did you get that
Same
too?
here.
Same thing. So if I would have done n minus 2 times 180 all over n equals 160, then I put that 160 times n equals 180 n minus 360 negative 20 equals negative 360 divided by negative 20. Okay, and I come up with n equals 18. You know what? I could have kicked all you guys' butts. Because if an interior angle is 160 degrees,
Oh, wow.
you did no work right over here. Very little, right? What's true about interior angles and exterior angles? So the exterior angle is going to be 180 minus 160. If I was to do this problem on tonight's assignment, I would not want to have to do work when I could logically think the exterior angle is 20 degrees. And since the exterior angles, no matter what type of polygon it is, adds up to 360, how many 20-degree angles will go into 360?
Wow, that's pretty cool.
Okay? Common sense?
Sure.
Okay, it sure does beat, okay, when we came back here to this problem, you know, right here, that we did all of this work, you know, right here, all I would have done is say, oh, my exterior angle, that's going to be 40 degrees. Okay, and I would have took 360 divided by 40 degrees and got 9 sides. And I believe back, first example we did that, I did all this painstaking work. Could have got it in one step. Okay? So, on tonight, okay, you have your worksheet, the point of intersection worksheet right here. Okay, your notebooks, you're more than welcome to do as I said with your notebooks, knowing that I will not grade them, and probably now that I've learned the leadership conferences tomorrow, okay, I probably won't even do anything with them tomorrow. I'll just postpone it till Friday. Okay, so I'll probably tell you the same thing tomorrow that I'm telling you now. Okay, but I didn't tell first and second hour that, so you guys really didn't hear me say that. Okay, then I probably won't be doing anything till Friday with them.
Well, no, I learned.
Okay, but they need to be back in that pile 8 o'clock in the morning. Okay, if you want to take anything you want with it, that's fine. If you don't have some of the worksheets done, like 4.7, I didn't check in because I didn't have enough time today to do so. You can take it with you. Your homework assignment is this. And you know, some of them are just very quick problems like this. You know, it's a lot of problems, but they're really not lengthy problems. The hard part is just showing your work. I would, yeah. You know, I would take your notebooks with you, and if you can get them in the pile at 8 o'clock, I'd do that. You know, if you don't want, if you can't, don't take your stuff with you. Okay, meaning your
Can I just
assignments.
take out, like, the notes from today?
I would. Yeah.
All right.
So after, like, a worksheet, is that, like, sections?
Just a second.